Now the final question, which is the third question. Find the acceleration of the masses and the tensions in the string as indicated below. Where sine theta equals to 0.6 and mu, which is the coefficient of friction, equals 0.3. We are asked to take acceleration due to gravity as 10 meters per second squared. Now, this is a system of bodies. Now, since 3G newtons is the greatest weight, then this block here, this block 3 kg, accelerates downwards. And as this accelerates downwards, this one also accelerates downwards along the plane by T1 and G sine theta. And of course, this final one, that is 2G newton. Now, we should also recall that since this block inclined at an angle of theta slides or accelerates downwards, then friction acts in the opposite direction and it operates at its maximum value. So that is why the friction will be equal to mu r in this case. And we have two separate strings here. The first one, we have it as T1, the tension in that string as T1, which means the tension transmitted here will also be the same here. So both will be T1. And for this second string, we can have that as T2. So the one transmitted here must be equal to the one transmitted there, and we have it as T2 each. Now, to find the acceleration of these bodies or masses, all we need to do is to quickly analyze the resultant on each mass and as well make use of the equations of motion. For this mass of 3 kg, now since it accelerates downwards, then 3g minus t1 must be the resultant, and that's why we have this, and this must be equal to 3a, which is from Newton's second law. And for this block of mass 2g here, you can see that this block or this mass accelerates upwards, which means that T2 minus 2g must be the resultant or net force, and that is what we have here. And this must as well be equal to 2a, also from Newton's second law. And finally, for this, since this block accelerates downward, the sum of these two forces must be equal, must be greater than the sum of these two. That's why we subtract this sum from this, and that is what we have here, and that also equals to a, also from equation of motion. Now, using each equation here, the first equation becomes this, since our g is 10, the second becomes g, and the third becomes this. Please, we should quickly recall that since sine 30 equals to 0.6 as given in the question, which is the same thing as 3/5, then cos theta here must give us 4/5, and that is obtained from Pythagorean, that is obtained from the right angled triangle actually. So going on with this, we will see that when we add equation 1 to equation, this is what we end up at the end of the day, and when we add equation 2 and 4, this is what we have at the end of the day, and that makes our acceleration to be approximately equal to 2.3 seconds squared. Now, to find the tensions in the string, has been obtained to be 2.3 meters per second squared. Now, from 1, which minus t1 equals to 3a, if I make t the subject of the formula, and then I have my final answer to be 23.1 newtons. To find T2, which is the second tension, and this is obtained from, and this is from equation 2, and making T the subject of the formula makes the value of T2, which is the second tension, to be 24.2 newtons. Thank you so much for listening for this section. Thank you. God bless. Peace.